In this video, we're going to look at the angle-side-angle congruence, which states triangles can be proven to be congruent when two angles on the included side, that's important, of one triangle are congruent to two angles and the included side of another triangle. So to clarify what an included side is, the included side connects the two angles. It is the shared side of the two angles. So if you look at these two triangles here, I have their corresponding sides highlighted the same color, as well as the associated angles from each side. And it's marked as such. Angle A is congruent to angle E, angle C is congruent to angle D, and side AC is congruent to side ED. If this is true, then triangle ABC is congruent to angle EDF by angle side angle. And again, with your congruency statements, you want to make sure that your corresponding angles are in the same position for each of the triangles. So let's look at example 1. Example 1 has everything filled out, but let's walk through it. We are given that angle BDC is congruent to angle ABD. So I'm going to go ahead and mark it. Angle BDC, that would be this one, and angle ABD is this one. And we are told that line segment AD is parallel to line segment BC. In an earlier video, I mentioned if you have parallel lines, look for congruent angles. And your choices are alternate interior, alternate exterior, and corresponding. Okay? So we start with what is given. Again, that's coming from up here. Because these lines are parallel, and this is the transversal, these two angles are alternate interior angles. Therefore, they are congruent. Okay? Again, notice that our two triangles have a shared side. And anytime you have a shared side or a shared angle, odds are you're going to use it in the proof. Segment DB is congruent to segment DB, reflexive properties. So notice what we have marked now. Okay, we said CBD and ADB. So if we look at this upper triangle, we have angle, side, angle. We look at this lower triangle, angle, side, angle. And so our two triangles are congruent due to angle, side, angle. Now, I want to caution you here, as I have throughout the videos, pay attention to the order of the vertices which represent the angles. So make sure you're paying attention to that when you're writing your congruency statements. So now we'll look at two examples, one partially filled out and the other one we'll take from scratch. So again, let me get this enlarged a little bit. We're going to look at what we're given and we're going to mark our diagram as needed. Angle E is congruent to angle H. And J is the midpoint. Okay? So since it is the midpoint, it will split EH into two congruent segments. Okay, so here's J, here's EH, so I'm going to mark this. Okay, so now I'm going to look at the diagram and notice that I have vertical angles. EJG and HJF are vertical angles. So I'm going to go ahead and mark those congruent because, as we know by the vertical angles theorem, All vertical angles are congruent. And now looking at my diagram, I have angle, side, angle, angle, side, angle. So now I can fill in the reasons. Again, number one is given. We know that EJ is congruent to HJ, definition of midpoint. We know angle EJG and HJF are congruent by the vertical definition of vertical angles, and therefore our triangles are congruent due to angle, side, angle. Moving on to example 3, we need to look at our diagram and see what is marked. Okay? So I have two angles marked the same, so that means angle A is congruent to angle E. And I have two segments that have the same tick marks. So that means segment AC is congruent to segment EC. And again, that is given. I don't have any right triangles or anything else like that. Then I want to look at what I have to prove. Again, these are sides. So I need to show congruent triangles, and then I can use CPC-TC. Okay? So our next step is, how do I show that these two angles are congruent? Well, just like in the previous example, notice I have vertical angles. So that means angle ACB is congruent to angle ECD. Vertical angles. Which now means I have angle, side, angle, triangle ACB is congruent to triangle ECD. Angle, side, angle. And so now, notice that AB corresponds to ED. Since they are corresponding sides of congruent triangles, they are congruent to each other. CPC-TC.